Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The starting diene is 2-methylpenta-1,4-diene, i.e. CH2 is equal to C, CH3, CH2, C, CH3 is equal to CH2, two terminal methylated carbons separated by a CH2 group, each with a methyl substituent. Moving on to the next step. Action of 2,8. KNH2 in liquid NH3. KNH2 is a very strong base. With terminal allenes or dienes, KNH2 in NH3, L, isomerase terminal alkenes to internal alkynes, or in this case, isomerase the double bonds. For a diene like 2,4-dimethyl, 1,4-pentadiene, two equivalents of KNH to deprotonate allylic propargylic positions and cause isomerization. The net result of treating 2-methylpenta-1,4-diene with 2,8. KNH2 in NH3, L is formation of a dianion, dienyl dianion or bisalylic dianion. Specifically, KNH2 abstracts the allylic protons from both terminal methylene groups, generating a stabilized dianion at the two terminal carbons of the system, CH2C, CH3 is equal to CHC, CH3 is equal to CH2 type dianion. The most stable dianion places negative charges at the terminal carbons, C1 and C5 of the original skeleton, after full deprotonation and resonance. Moving on to the next step. 1 equivalent of N-butyl bromide alkylates 1 terminal carbanion. Since 2,8. KNH2 generates a dianion, alkylation occurs at the less hindered terminal carbon. The N-butyl group attaches to one terminus. And for the final step, protonation of remaining anion and hydrolysis of any enol forms. The enol tautomers of the allylic vinylic system tautomerase to ketones upon aqueous acid workup. Starting from CH2 is equal to C, CH3, CH2, C, CH3 is equal to CH2 after dianion formation and monoalkylation at one terminal carbon with NBU, followed by acid workup. Tautomerization of terminal is equal to CH2 or is equal to C is equal to O via enol. The product is a 1,5-diketone. The two terminal is equal to CH2 groups each become CH3. C is equal to O after tautomerization. D is equal to C, CH3 becomes C is equal to O, CH3 type. With one NBU group added at a terminal position, the product is CH3C is equal to O, CH2C is equal to O, NC4H9, i.e. 1 N-butyl, 4-pentanedione type, which corresponds to a structure with two ketone groups and a butyl chain matching option D, which shows two ketone groups with a butyl substituent on one end. Option A shows alkylation at the central carbon, C3, giving a 3-substituted 2,4-pentanedione with a pentyl chain, wrong regiochemistry and wrong chain length. Option B shows a longer chain suggesting different connectivity. Option C shows a propyl group instead of butyl. Option D correctly shows the product of terminal monoalkylation with N-butyl followed by tautomerization to give a diketone with the N-butyl chain at one terminal ketone carbon. Therefore, the correct answer is D. Therefore, the correct answer is option D.